Okay, let's do some multiple choice. Here's this marketing survey, and they're looking at people that own cars. They're not going to ignore the houses that have more than 5 cars. That's kind of a rare case. So, what is the probability the randomly chosen household has at least 2 cars? Which means they have 2 cars, or 3 cars, or 4 cars, or 5 cars. Add those all together. And the answer is D, 39. Oops, there we go. What? There, D. Okay. What is the expected value of the number of cars in a randomly selected household? The expected value. So how do we figure that out? Aha! Number times probability, number times probability, number times probability, all the way down, and add them all together. Okay. So, what is that? So, if you multiply all of these, this times this, 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 this times that, multiply them all together, these two numbers, and then add all your results, you should come up with 1.45, which is C. Okay. Letter 3. So here's the situation. Dealer in Las Vegas selects 10 cards from a standard deck of 52. Let Y be the number of diamonds in the 10 cards selected. Which of the following best describes the setting? Well, it's definitely not geometric, because that's deal until you win, right? Until you get a diamond. So let's see. It's got to be C. So where n equals the number of observations, probability of 0.25, because there's 4 suits in the deck, provided that after selecting the card they replace it back in the deck and shuffle it. Yes. Let's go to number 4. So on this one, number of cell phones in the house. They just ask you for the standard deviation. So I would put this into L1. I put this into L2 in our calculator. And go to Stat, calculate one variable statistics. Make sure you put L2 in the frequency list and see what you get. And you should get A right there, 1.7475. Okay, next. Okay, definitely a couple of tricky ones in here. So let's see. This one, what? So I know that the sum has to add up to 1, right? So if this is 0.07 right here, and this is 0.03, that adds to 0.1 if you add them together, which means these two together have to add up to 0.9. 4C plus 2C equals 0.9. That's an algebra problem. So that would be 6C equals 0.9, and then divide by 6, and you should get your answer. Wait, no. Well, let's divide by 6. Yes, that worked. Divide by 6. Divide by 6 on both sides, and you should get 0.15, which is letter B. Okay, what's next? So number 6 is kind of tricky because the variance of the sum is the sum of the variances. And don't forget, the variance is really the same thing as the standard deviation squared, right? That's the variance. Worst pen ever. Okay, so let's see, we can cross this one off. And let's see. What's next? Oh, and we can cross this one off because those are standard deviations. So now we kind of just have to think about B, D, and E. And they do have to be independent. Okay, we keep saying that in like every question, like the bins, are they independent? So there are questions, anyway, well, I'm not going to go into it, it's just this one. Okay, that's enough. Let's do the next one. Well, let's see. Number 7. We've got, let's see, 18 widgets. 90% are good. And what do we want? We want the mean and the standard deviation. So it's the mean is going to be 18 times 0.9. The number times the probability. There we go. Well, that doesn't help, does it? Oh, it does. 16.2. So that rules out the first two. 16.2. So now we do the standard deviation, which is going to be the square root of 18 times 0.9 times 0.1. That's how we figure out that standard deviation for that. So what is it? And that works out to 0.127. Letter D. Okay, letter D. Okay, this is a pretty good raffle because for $10 you have like a 40% chance of winning a pretty good prize right there. Unlike that sober grad raffle, now I've worked at Corning High School for quite a number of years. I have never heard of anyone winning anything from that raffle. I'm happy to support sober grad. I think it's a great event. Just take my $10. Here, you can have it. But don't tell me that I'm going to take a trip to Cancun or win 5 huge giant screen TVs or whatever, a Jeep, a gold Jeep or something. Just, the prizes are ridiculous. Nobody ever wins. Anyway, so I am really getting tired. Let's see what we have here. So the expected profit is, again, here we go. We're going to multiply the prize times the probability. Outcome times probability, outcome times probability, outcomes times probability, and add them all together. So let me do that. And it says that the answer is B, but I keep getting 595. I'm not sure why. 595 as the expected value. So, anyway, let's go to the next one. Whoa. I'm going to save number 9 for a second. Let's do number 10. Okay. Which of the following random variables is geometric? Remember, you go until you win one time and then you stop. Okay. The number of phone calls received in a 1 hour period? Nope. That doesn't make sense. The number of times I have to roll a 6-sided die to get 2 5s? No. Geometric is you do it once and then you stop. C. The number of digits I will read beginning at a randomly selected point in the table and find a 7. That sounds pretty good. I like letter C. The number of 7s in a row of a random digit table? Nope. All 4. Okay, I think it's letter C. And that is correct. Now let's look at this one. This one's kind of tricky. So, let's see. Number 9. Let the random variable represent the amount of money Carl makes tutoring statistics students in the summer. Assume X is normal with a mean of 240, standard deviation of 60. The probability is approximately 60%. that is, in a randomly selected summer, car will make less than about how much money? Okay. Tricky, tricky. Okay, let's see. Well, it's a z-score. It's a z-score, right? So it's the number we're interested in minus the average, which is 240. They give us that. They give us the standard deviation, which is 60. They don't tell us what that is. That's what we're looking for, and we got to figure out what the z-score is when we get a value of 0.6. We haven't done this in a long time, so basically 60% of our graph, right? We want to know where is 60% of our graph. How many standard deviations above the average are we when we have 60% of that? That's what that's saying. So we do inverse norm. I'm going to do that. And it says it's at about 0.253, about a quarter of a standard deviation above the middle. So 0.253 is equal to x minus 240 over 60. Okay. Let's see. Solve for x. Multiply by 60 and then add 240. So there you go. Let's see what that is. So when you solve for x, which you should be able to do, right? Get x by itself, multiply by 60 on both sides, then add 240, you should get 255, which is the answer to the question. Let's see. Car will make less than about that, $255. Letter C. Okay, done for tonight.